morning everyone. Today we will discuss the operation of a circuit breaker and the arc formation in a circuit breaker and arc extinction methods. Good morning everyone. Today we will discuss about circuit breaker. So this is last class we had discussed about the fuse and its operation, types of fuses. So a fuse is a one which breaks the circuit under abnormal conditions or under faulty conditions. Similar to the fuse is a circuit breaker, but there is a slight difference between the fuse and the circuit breaker. The fuse breaks the circuit, then it cannot make the circuit. So that means we need again, if it is a rewirable fuse, we need to again rewire it, or if it is a HRC fuse, we have to replace it. That is, a fuse will operate only once in its lifetime, whereas a circuit breaker can operate any number of times. So now we have the introduction, operation, production of the arc and extinction of the arc. So these are the topics which we discussed today. So circuit breaker. So circuit breaker is a piece of equipment which consists of two types of contacts, fixed contacts and moving contacts. In normal on condition of a circuit breaker, these two contacts are physically connected to each other due to applied mechanical pressure on the moving contacts. Whereas under faulty conditions, these two contacts get separated from each other. If at all you want to operate this under normal conditions, we can operate it either manually or by remote control. Under faulty conditions, the circuit breaker will automatically operate. Once again, if we want to make a circuit once the fault or abnormal condition is over, then we operate it manually or by remote control condition. So how does this operate? As I had said, the circuit breaker consists of fixed contacts and moving contacts. These are called as electrodes. Under normal operating conditions, these contacts will remain closed, and under faulty conditions, these contacts get separated by a mechanism. So now if you see here, here this is the fixed contact and this is the moving contact. Under normal conditions, these two contacts are intact with each other. So the power flow will enter from here, then it will go to this bimetallic strip, a latch, the operating coil, then this movable contact and fixed contact, and this is the lead. So if you look at the basic difference between a fuse and circuit breaker, so this entire part is being replaced by a fuse wire between these two contacts in the case of a fuse, whereas here there is a mechanism that is separating these contacts. Right. Whenever the contacts of the breaker start separating, the contact resistance starts increasing. So why the contact resistance increases under the operation of the circuit breaker? The reason being is, so there is you are making a gap, you are creating a gap between the two contacts. So that means these are being electrically separated, that is, the resistance is increasing, that is, a open circuit is being created, the resistance is increasing. The large current is there because of the fault. So this large current square multiplied by the large resistance produces great amount of heat. This heat increases the energy of the electrons in the contact areas, and the ionized particles try to maintain this current. So when the contacts are separated, this flow of charged particles from one contact to another contact is called as an arc. So actually we will see this arc phenomenon. How does this occur? So under normal conditions, the fixed contact and movable contact are intact with each other. Now these contacts starts separating. There is a spots of this contact. If you see here, these start separating. So when the contacts start separating, they the voltage between these two will be very small, but the distance between these two is still smaller, thereby the voltage gradient, that is dV by dt, is very large. This large gradient is sufficient to break this gap between these two. So that means the dielectric that is existing between these two is broken, and that it appears to be a continuous path of current. So that is, though the contacts are physically separated from each other like this, but they are electrically in contact with each other. So that is, an arc is resulted because of this. So the arc even continues, even the breaker contacts are separated. The potential, that is the potential gradient, is less. So it continues even for low voltages also. So how do you break, that is, you extinct this arc? So that means what? We need to suppress this arc at any means. Why? The very purpose of this is we need to separate this contact. So that is, we need to break this circuit. But whenever an arc is existing, it means that the flow of current is still possible, is still taking place through this arc path. So we need to break this circuit. So there are two methods being employed. One is called as high resistance method, another is called as a low resistance method. So whenever you separate the contacts of the circuit breaker, at that time, if we start increasing, by some means increase the resistance of the arc, thereby the potential difference between the contacts is unable to maintain the arc current, and we can break the arc. Otherwise, if you by some means, if you deionize the ionization, that is the ionized particles that are there, if you start deionizing this, that is, if the arc path is deionized, then the arc extinction is facilitated. So there are many methods of deionization, that is cooling the arc, lengthening the arc, that is extinction of arc, and cooling the arc, lengthening the arc, or by use some other material such that this arc can be extinguished. So now if I see, I will show you this that right here, that is high resistance method, how it is employed. If you look here, this is the arc runner. So whenever the arc exists between these two contacts, this arc is made to force into this, what is called as arc splitter. So this arc will be like this. So whenever the arc is forced into this, the length of the arc will increase, whereas the area of cross section of the arc gets decreased. So since R is equal to rho L by A, length of the arc being increased, and the area, that is area of cross section of the arc, getting decreased, thereby the resistance of the arc increases, thereby this cannot sustain, and thereby the arc starts splitting up. So that means we had achieved our aim of separating these two contacts electrically from one another. So that is, the circuit breaker is serving the purpose of breaking these contacts, that is breaking the circuit. That is, this is not having a contact, the input electrode is not having a contact with the output electrode. Under that condition, this operating lever will be in this position, downwards position. So next class we will see about various types of circuit breakers depending upon the medium which we are using as the dielectric. Depending upon that, we do have different types of circuit breakers. So thank you.